The information and examples included in this summary presentation are designed to support the learning of Course Objective 3.2, which addresses survey response data types. Now, this objective includes topics related to survey design, which is associated with research design in general, but is probably more focused on positive research designs. Surveys, however, can and often are used in some interpretivist models. This objective can be applied within the development of the third part of the course project as you define your methods and procedures. So the overall objective for this is that you should be able to categorize survey response formats as either dichotomous, nominal, ordinal, interval, or ratio. So let's take a look at each of these more closely. So survey data is almost always translated into some type of number. And those numbers can be regarded in terms of data types as nominal, ordinal, interval, or ratio. And there is an order to the complexity of the data types that are going to be presented. And I like to remember the order by thinking about the word noir, which is, of course, if you think of film noir, it's these smoky black and white films with lots of contrast and lots of shadows. But as an acronym, it seems to help me remember the order of complexity, nominal being the most basic form and progressing through more complex forms of data. So let's take a look at these individually. First, there's nominal data. Now, nominal data reflects data where the numbers are assigned to categories. The differences between the numbers don't mean anything. That is, there's no mathematical significance in the numbers other than differences in categories. And if there are only two possible categories, then the nominal data is regarded as dichotomous. So let's take a look at some examples. Suppose you were given a survey, and on the survey you asked the respondent to indicate what religion that they were currently practicing. And maybe you had 4 or 5 different choices, and you assigned a number to them. So if somebody recorded that they were Baptist, they would be a number 1. If they said they were Catholic, that would be a 2. Mormon might be a 3. Muslim might be a 4, etc. So you'll notice that those numbers don't mathematically mean anything. There's no value to them. They simply correspond to a particular category, and that's it. Another good example would be occupation. So you said, okay, which of the following occupations do you currently practice? And you had a list, and there might be 15 or 20 different occupations, including currently unemployed. Now, each of the numbers that you assign to those occupations don't mean anything other than the category or the occupation that they correspond to. Political affiliations is also a real common type of nominal data that's collected. Same with class. That is what socioeconomic class you might belong to, perhaps based on your annual income. Even your sex, whether you are male, female, or some variation of that, some genetic variation of that. That's generally dichotomous because most people are either male or female. Of course, there are variations where people have chromosomal differences that result in actually being both male and female in terms of genetics. That's another category. But typically, it would be male or female. And if you wanted to record gender, that would not be dichotomous because how you identify with your gender could be male, female, or some other variation of that. In terms of gender as a construct, and I'm not talking about sex as a genetic reality. Now, of course, sex is generally dichotomous, but not always. There are intersex organisms, humans, along with every other living organism out there that is a variation on what is considered, genetically normal. And of course, many yes or no items would be considered dichotomous. So you might assign a yes a 1 and a no a 2. That's nominal data. Those are all real common examples of that. So let's take a look at ordinal data. Ordinal data are where the numbers represent a hierarchy or some kind of rank ordering, so different from nominal. And the differences between the numbers mean something, but the differences between them are not equal. So let me talk a little bit about some real common examples of ordinal data. So ordinal examples include level of education. You could have on a survey somebody mark what's the highest grade level that you successfully achieved, or they could be categories where you select the highest was elementary school or high school or 2-year community college or 4-year degree or graduate degree, etc. Now notice that if you assign numbers to those where somebody who never finished elementary school would be given a 1, and somebody who finished elementary school but no further got a 2, and somebody who finished high school got a 3. There is an order to those numbers. They mean something, but the difference between a 0 and a 1 or a 1 or a 2 doesn't really, they're not equal. Attitude survey responses is another real common example of ordinal data, where you ask somebody to rate their level of agreement to a particular statement. This class is interesting. And they could rate it as strongly agree, which might be a 4, agree is a 3, disagree is a 2, and strongly disagree is a 1. But if you think about it, if the difference between agree, which might be a 3, and disagree, which might be a 2, the difference between those numbers sort of conceptually is probably very different from the difference between a strongly agree, a 4, and an agree, which is a 3. So attitude survey responses are a very common form of ordinal data. So let's take a look then at interval data. Interval is where the numbers represent a particular hierarchy and order, similar to ordinal, but the differences between the numbers are relatively equal. However, there is no true 0 on the scale, on the interval scale. So let's take a look at some examples of this. An IQ test is a norm-referenced measurement of your performance on a particular set of cognitive ability items. And depending on your score is referenced to everybody else who took it. And if you are roughly the average, then they give you a score of 100. And if you are a certain amount below, you get a score that's lower, and a certain amount above, you get a score that's higher. And so IQ test scores can range from very low in the 60s and 70s to very high in the 160s and 170s. And the difference between 100 and 110 is roughly, conceptually, the same as the difference between 90 and 100. However, there is no 0 in norm-referenced measurements. But the distance between the numbers is relatively is meaningful and relatively the same. All other common norm-referenced measurements are the SATs, the graduate record exam, the GRE, the law school admissions test, the LSAT, medical school or medical college admissions test, and any other norm-reference tests. The data from those, the numbers that those represent, are all interval. And I do want to say that the reason why identifying the different types of data is important is that it helps you decide how you're going to analyze the data, what you're going to do with those numbers, and what those numbers mean. So it is very important when it comes to the analysis phase, and I'll talk more about that when we get to the data analysis. Now, finally, if you're following along the NOIR acronym, then, or mnemonic, if you will, we have ratio. Now, you might have guessed, ratio data represent numbers that are in a particular hierarchy and order. The differences between them are relatively equal, but there is a true 0 on the scale of ratio data. So let's take a look at a few common examples. If you ask on a survey the number of siblings that somebody has, whatever number they give, that data would represent a ratio. If they said, I have no siblings, 0, then 0. There is a 0. It is possible to have no siblings. If they said they have 1, or they said they had 2, 2 is twice 1. So if they said they have 2, they have twice as many as 1, etc. So that's a common example. The amount of money that you earn. You could earn $0. You could earn $100,000. You can earn $50,000. If you earn $50,000, you are earning half of someone who earns $100,000. So that data would be ratio. The number of arrests that you currently possess. That would be ratio. 0 or 1 or 2. Those numbers. There is a 0. Some of you might have been arrested 0 times. Congratulations. But again, 1 is more than 0 and it's less than 2. And if you have been arrested twice, then you've been arrested twice as many as 1. And finally, even performance on criterion reference tests like this particular course. That's an example of ratio. You can get a 0 on the test that I give. You can also get 100% or all possible items, and I'm still waiting for some of those. So so not all test results are interval. Some can be ratio, like this class. So those are some examples. Let's take a look then and see. Let's apply this to a few real world examples and see if you can conjure out of your brain right now whether they are nominal, ordinal, interval, or ratio. And remember that if you can recall the mnemonic noir, then you can at least remember the general order of complexity that these are. Okay, first one, distance. Distance as measured by some device like a ruler. What type of data is that? Nominal, ordinal, interval, or ratio? I hope you realized it was ratio because there is a 0 to distance. Something could be 0 distance away from something else. And if something is 10 centimeters away, or 10 kilometers, or 10 miles away, that is half the distance as if it were 20 centimeters, or 20 kilometers, or 20 miles away. So distance is definitely a ratio type of data. Now, what about attitudes on an attitude survey? Nominal, ordinal, interval, or ratio? Hopefully you recalled back to the notes and realized that generally they are ordinal. Although I will tell you that it is very common for researchers to translate attitude values into numbers and to treat those numbers and analyze those numbers as if they were interval. And that can be problematic, and it does affect what kinds of statistical tests they might run on it. But there's different schools of thought as to what is most appropriate. What about GRE scores? GRE scores are norm-referenced test scores. Now, hopefully you remember that those would be interval types of data. What about scores on a Virginia SOL test? For those of you who are teachers, you might be more familiar with this type of scoring. Now, this is kind of a trick question because the scores on a Virginia SOL test do start out as ratio scores. The raw score is ratio because students can get a 0. You can get a 0 on an SOL test. And you can answer all the questions correctly. You can. So there is a true 0. However, all the scores are normalized once the raw scores are inputted into the system. So the final score that someone receives on an SOL test is not the raw score. It has been norm referenced, and the score would represent an interval. Now, I do want you to know that I will not be asking any complicated types of categorizations on the course exam, like this. And speaking of which, What would the score on the upcoming social science research exam be? What kind of data would that number represent that you earn? And hopefully you remembered, yes, that would be ratio, because you could get a 0 on it. I hope you don't, but you could. And if you got a 15 on it out of 30, that's half as well as someone who got a 30. And what about marital status? What type of data is that? So let's say you have choices: married, not married. Well, really, that's kind of it for marital status. I mean, there might be variations like common law but not legally married, or living together, or whatever. But generally speaking, marital status is nominal. Now, I would not ask on the test whether or not this was dichotomous, because, as I mentioned, you could probably come up with variations on marital status that go beyond the typical yes or no. And what about letter grades? This is interesting. Let's say that an A is a 4.0, and a B is a 3.0, and a C is a 2.0. So think about that one. What would that be? Also a little tricky. It could be ordinal, I think. It could be ordinal or interval. Now, the reason why I say ordinal is because I don't think that the difference between a B and a C, between a 3 and a 2, I don't think it's the same as the difference between an A and a B. I think there's a greater gap. There's a bigger cognitive difference between earning a B and earning a C, especially in graduate school. But I think in general, you might argue that there is some value attached to these numbers that go beyond just one number difference. It's a different value. So I would definitely argue that letter grades are ordinal. However, you could also argue that they're interval, because the fact is a 3 is 1 less than a 4, and a 2 is 1 less than a 3. Again, I will not be asking anything that is this tricky on the exam. I will make it very clear. You simply need to apply the fundamental concepts of different data types to the concepts that I present, and or to the examples that I present. And remember, we will revisit data types when I review with you the different ways that you might treat data when you're analyzing it, because different statistical tests are appropriate for data that are nominal versus data that are ordinal or interval or ratio.